Right. Now, I know I say that quite a lot. Right. Anyway, the Tokamak design for light technology and for the internal power system for the spaceship. Now, the applications of it is just containment. So you contain the relevant energy structures, and you contain the relevant gases, and you contain all of the relevant fission. Now, there are different types of fission. There is electric fission, and there is uh, gas um, ignition. So you've got um, you've got gases, and they're inside a containment. Now, the containment will have the very thing that we were talking about before, which is the laser field. Now, the internal of the tokamak will be coated with a laser. It's a wideband laser which will cover the whole interior of the whole framework. And the interior of it will be a containment. So it will contain the actual gases, and it will contain the plasmas, and uh, it will contain the electric. Now, it will be a mix of gases which are ignited, and then there will be a mix of electric current that flows through it. And because it's a mix of two things, because it's an electric tokamak, so it means that it will hold the structure of of a very similar design, which is the donut shape, which is everyone seems to be using at this moment in time. It's also, for me, a representation of dark matter containment area. And because it's an area of dark matter containment on top of everything else, which is basically just on top of everything. So you're going to have your donut shape, and then you're going to have your laser field containment inside it, and then you'll have your gases inside, and then you'll have your electrical current. So it's going to look very similar, at least for the time being. It's going to look very similar, where the central core of the actual tokamak. So if you can imagine the usual shape, it's either a pillar, right, or the usual donut shape, which is this circular shape, right? In the center of that, there will be, there will be the electrical current generator. So it will be a rod with a ball in the center on top of it, which is just like the other desk unit that you would get, and you'd place it on your desk and it would just spark away, right? Very simple. So you have like your central core, which is which is very similar to the core of the sun, right? And then it will have its connection to the chamber, and then it will have its laser barrier and its containment. Now, the laser barrier and the containment will be tailored so you can strengthen the field and strengthen the containment, and give an area of protection, should we say. It also contains the temperature, so it will contain the temperature of the actual tokamak, and it will be an integral part of the sensor device or the sensory part of the tokamak. It will keep an eye on all the temperature on the outside and the inside of the actual tokamak itself. And because you can strengthen the field and strengthen the containment of it, you can compress it, which means you can compress, and not only compress, but you can compress all areas of it. So you're going to have your magnetic field that will be around it. You'll be able to see the field through the laser barrier. Well, because of the laser barrier actually applying itself to the actual magnetic field. And then you're going to be able to compress the chamber containment. So you'll compress the chamber containment by controlling the gas, and you compress the gas to a density which will be enough. Now you need a gap in the space between the outer inner wall and it's a cooling area. This area is the cooling part of the tokamak. So you will get fission compressed, and when you compress the fission, initially it'll all be loose gas, and then you'll tighten the compression and it will become dense in its fission. Now we're going to run electrical currents through it. So we're going to have electrical current sparking off and hitting the outer casing or the inner outer casing of the actual tokamak. Now this will produce various areas of fuel requirements, and it will produce new gases. So we basically tailor the electric current and electric field to produce the new gases that will be included into the. So when you compress the containment chamber and compress the plasma, the outer cooling zone, which will be cooler, I mean it's not cool, but it will be cooler than the actual compression of the actual plasma. And because it's something which allows you to build up extra gases on the outside of it, right? So you will have density of plasma, then you'll have gas production through various areas of natural production. And then there will be, so you'll have like a thinner layer. So you'll have a thinner layer of gases, of newly generated gases, which will build up over time. This is not something that you can, it's not something that you can physically build up very quickly. But you can fill it full of gas very quickly, and you can ignite what you've got. And because you can tailor it in light technology computing, you'll be able to offset the gas production eventually with the inclusion of the ignition. Now the idea is that the laser will contain what you require as your energy source, and the outside of the laser will contain the new gas production. Now obviously the temperature and the heat will have to be controlled, and you will be able to segment your areas of dark matter. So you've got your inner chamber, which is a dark matter chamber, and then you're going to be able to manipulate your dark matter, and then you're going to be able to place regions in dark matter to be able to or pinpoint hotspotting. Now you'll be able to hotspot in the ignition part of the compressed plasma, hotspotting there in various places, right? And you will be able to manipulate your hotspots. So you'll be able to manipulate and move and unify your hotspots. Now we're going to unify it through a mild resonance and a mild vibration. And what will happen is that eventually, once you have all the system in place of the outer casing created and built, you then will be able to manipulate the plasma structure. So once you've got your plasma and you've got it stable and you've got your gas production build-up, you will then be able to resonate plasma patterns into the chamber. Now, because it's going to be controlled by magnetics, right, you're going to be able to manipulate this plasma. Now, the natural form that it will take in a 360-degree environment, right, will look very similar to a star structure radial pathway, right? Very similar. In fact, it's not similar, it's exactly the same, but you're using resonance, and then you're concentrating your hotspots in various areas, and then you're going to also generate cooling zones. Now, in the sun, you've got black spots, right? And the black spots of suns are randomly created by the sun itself. Now, what will happen when you resonate and you manipulate your plasma structure into a 360-degree pattern, right, of radiational pathways, which it will be radiational pathways eventually, right, once you've resonated it enough to be able to stabilize it. All the gaps in between the patterns are all your areas of dark matter cooling, right? So dark matter cooling will basically kick off. And because dark matter cooling will kick off in all these areas of empty space, because the rest of it is all in hotspotting and channeling to various other hotspots all over the place, right? So it will make a 360-degree pattern all the way around in the chamber. And then what we're going to do is that we're going to turn up the ability to be able to increase not the temperature, but the temperature will increase, but it's to increase the density of the pattern to almost, let's say, a white light structure, because it will glow, and depending on the gas that you're using, it will glow. Now, we're going to play around with waveband coloration in the actual tokamak itself. There is going to be an outer casing, which will be solar paneling or just sensor equipment, which is solar paneling really, and it will generate electricity through its radiance. Then we're going to play around with the best form of color that will produce a good electric current through the solar panels. And once we've got all this put together, and we've basically built the structure of its stable state, we're going to try rotation. So we're going to try rotation because it will be a 360-degree pattern with its dark matter cooling spots of black spots, and then it will rotate under magnetics. So we're going to rotate it under magnetics. Then we're going to use the containment field that contains it. We're going to release the containment field gently, and it'll expand naturally, keeping its natural pattern and its natural shape until it touches the inner casing. When it's touching the inner casing, there are going to be other sensory devices. Now, this is an old way of working when it comes to hotspots hitting receptors that will generate electricity. Now we're going to play around with the distance, and we're going to play around with the gap, and we're going to play around with the best form or the best distance and gap when this thing's rotating. So when it's rotating around the chamber, it will be hitting, all these hotspots will be hitting these sensors that are built into the inner outer casing. And as it rotates, it will generate a current. And as it generates a current, it will spark off into the into the sensor. And then this electrical current, which is generated, will be taken out and basically stored. So every time it rotates, so the faster it rotates, the more electric current that it will generate, as well as generating its energy into solar paneling. So, and then we're going to turn it up, and we'll turn it up into, like I say, waveband structures, and turn it up into almost like bright light. And I'm hoping that we can build out of this structure a physical energy Now, it starts off in a gas as plasma, but it's compressed because electricity is plasma, but it's extremely concentrated plasma, like a lightning. So if you think of the atmosphere of our planet and how the clouds build up and the gases of the clouds build up and all the environment of the storm builds up, then it basically starts to do all sorts of things, which is resonate. And then it starts to build up all sorts of energies in the cloud. And then it goes blue, and then it starts to, and then it would go, right? So that's the natural atmospherics that we're going to build inside the Tokamak. And all it is electrical current. And because we're going to build this thing, and we're going to put it all together, and we're going to hold it together in atmospheric gases, but it won't be Earth's atmospheric gases, right? Now, if you think of other planets that have got structural gases that are in the atmosphere, right, that build a lot of electric current, okay, we've got a perfect planet in our solar system that does all of this, right? And it builds up all of this electrical current, and it contains it. And it has all of its dark matter coolant around it. And it has all of the things that it needs to be able to generate this natural energy. So we're going to build the environment of natural and use different types of gases. So there may be one tokamak that is designed with one particular gas in mind, and an atmospheric and a magnetic field. And I'd like you to remember, the scientists that are out there, our our magnetic field, right, also compresses at times, and it expands, and it compresses, and it expands, and it compresses, and it expands and compresses. Now, there is a lot of stuff that goes on. I mean, we've got like the snap that kicks off, and it basically whips itself back into our atmosphere and compresses all the gases. I mean, and pressure build up and various other natural effects. And because you can do all of this and then isolate it in areas, it will be the most natural energy structure and the safest, most energy structure, far safer than nuclear, and far safer than any other nuclear power plant that is being planned and being built today. It will be far, far safer, and you will be able to control it, and you'll be able to manipulate it, and you'll be able to concentrate the plasmas into physical energy. Now, the idea is, if we can build enough plasma which is ignited and then compressed and then generates electric energy, the idea is, once you've compressed it and you've basically been able to put it into its containment of vacuum, we will control it even further. So we will create a compression in the vacuum, and we will build something, hopefully, of liquid electricity. Now, liquid electricity is something which you can basically put together and compress, but because it is something that is controllable, and you would be able to create and build the necessary safety structures for it to be able to do all of this little tiny hotspotting, right? So you build everything to a compression, and then you try to create a liquid electric. Now, all of this would only be in space environment for liquid electricity to exist. But there is another form of liquid electricity, which is from a plasma, and and it exists in our atmosphere, and it's called ball lightning. Now, ball lightning, when it's been examined by scientists, if you can pop several of these items of ball lightning, which is in the Earth-type atmosphere, and because they are generated and they drop to the ground and they can hover and move around the place and they can maintain their containment, it's always the conditions in which it was created is the only time of where it actually lasts, which means changing the structure of the atmosphere in the Tokamak will naturally, will naturally allow it to go out. So it would fizzle out naturally into its new environment, which you've just introduced. So you could compress it all and get it all nice and up and running, and then you can change the environment and loosen everything up a bit, and it'll all just go, and then it's gone, right? But during that process, you'd be able to take the energy from it and take the energy out of it and use it electrical current. So the safety would be that the Tokamak is created and built to be able to control the atmosphere. And once you can control the atmosphere, then we'll be able to build one on Earth. If you want one in space, which is possible, you will then have to create something which would exist in space and compress it and condense it so it's liquid electricity. So it would be like a little contained neutron. So it would be a little contained neutron star, right? But we're talking utterly and totally controllable. Because if any of it broke or if any of it became unstable or unsafe, in space, it would just dissipate safely into its environment. And if we work on the area of ball lightning and creating ball lightning in certain atmospheric gases, then it's the same thing. If the Tokamak broke, or if the Tokamak lost all of its power, or if there was just something that was classed as being dire, the whole thing, because of the change of environment or the break in the environment or the break in the machinery that changes the environment, it would just dissipate and go out. So if you build the safety structures of creational nature into it, then it's not dangerous. The structure isn't dangerous at all. And if you build regulations of compression and regulations of energy density and all regulations where you don't go past any of this kind of activity, but there is also other things that you can do. You'll be able to test the structure of it and test the dangers that might be lurking there for those people that have doubts. So you'll be able to compress it to the point where it would either turn into something and then and then it's just a case of seeing whether it dissipates safely. Now, we're not talking explosions, really. We're talking fire. So we're talking natural fire and natural energy that is compressed from fire into physical electricity. And because let's say we take the value that it's just burning fire, that you can put it out in various different ways. So you can control it by atmospherics, or you can control it by smothering, or you can control it by all sorts of things. So this is the structure of the future plans that we're going to put together and that we're going to create and complete. And it will be far safer than nuclear, far safer than splitting atoms, far safer than over-radiation metals and all sorts of other dangers. And because it's safer and you will be able to get light from it, you would be able to produce several stacks of energy drain actually from it. And if we match the energy drain from the unit, we're then going to be able to produce as much energy as we like. And we'll be able to store it in new storage units. I mean, I've got a new storage unit basically being developed, which is a conduit storage energy unit. And I'm going to have these in my ship, right, my spaceship. But the central core will be my new Tokamak, right? So it will be the electric Tokamak, and it will produce all these natural environments, and then it will produce lots of good energy. And then I'm going to store that in my conduit storage areas. So this is the LTS-Q, which is the new design for the actual Tokamak itself, which is like technology science, Quontam. This is Michael Ian Hammond, ECO, and let's hope that you all get to enjoy this new renewable energy.